You don't hear it coming. There is no siren, no warning sound, no moment where the sky cracks open like in the movies. It begins quietly far beyond Earth, on the surface of the sun. A sudden flash of light erupts from a region that has been unstable for days. In less than 8 minutes, radiation reaches our planet at the speed of light. Satellites register it first, then instruments on the ground. Then systems you depend on every day. Most people don't notice anything at all. Not yet. But in 1859, they did. On the morning of September 1st, British astronomer Richard Carrington was sketching sunspots when he saw something no human had ever documented before. 2 blinding white flares exploded from the sun's surface, brighter than the surrounding solar disk. He stopped drawing. He knew this was different. Within hours, Earth responded. Telegraph systems across North America and Europe began to fail. Sparks flew from telegraph machines. Operators received electric shocks. Some offices caught fire. Others continued transmitting messages even after being disconnected from their power supplies. Energized by the storm itself, the night sky turned unfamiliar. Auroras appeared where they had never been seen before. Red and green lights danced across the sky as far south as Cuba and Hawaii. Newspapers reported people waking up at night thinking the sun was rising early. It was beautiful and it was dangerous. This event became known as the Carrington event, the largest geomagnetic storm in recorded history. In 1859, the world survived it, not because it was harmless, but because the world was unprepared in a very specific way. There was almost nothing to destroy. No power grids, no satellites, no GPS, no internet. The technology that defines modern life simply didn't exist yet. Today, everything does. And that's the problem. What Carrington witnessed was the result of a massive coronal mass ejection. A billion-ton cloud of magnetized plasma hurled from the sun directly toward Earth. When it collided with our planet's magnetic field, it triggered a chain reaction that overwhelmed the systems of its time. In 1859, the damage was limited. In the 21st century, it would be catastrophic. Modern civilization runs on invisible threads. Electricity flows through thousands of miles of high-voltage transmission lines. Satellites orbit Earth, maintaining communication, navigation, banking, weather forecasting, military operations. Data centers pulse with information that never sleeps. All of it is vulnerable. A storm like Carrington would not announce itself with flames. It would announce itself with silence. Power grids would begin to fail, not all at once, but in waves. Transformers would overheat. Protective systems would trip. Some components would be permanently damaged, requiring months or years to replace. Entire regions could go dark. Satellites would be disabled or destroyed by charged particles. GPS signals would degrade or vanish. Aircraft would be rerouted or grounded. Financial systems that rely on precise timing would lose synchronization. Phones would stop working. The internet would fracture. And unlike a blackout caused by weather or human error, this would not be local. It would be global. In 1859, people wrote letters about glowing skies and malfunctioning machines. If it happened today, there would be no tweets about it, no live streams, no real-time explanations, because the systems that allow us to understand disasters would be among the first things to fail. What makes the Carrington event truly unsettling is not that it happened once, it's that it can happen again. The sun is not finished with us. Solar storms are not rare. Smaller ones hit Earth regularly, usually deflected or absorbed by our magnetic field. But occasionally, the alignment is perfect, the timing exact, the energy immense. And when that happens, the damage scales with our dependence on technology. In other words, the more advanced we become, the more fragile we are. Scientists have found evidence of even larger solar storms in the distant past, events that predate modern instruments but left traces in tree rings and ice cores, storms that may have been stronger than Carrington. We were lucky they happened before electricity. Luck is not a strategy. Today, governments quietly prepare contingency plans. Space agencies monitor the sun continuously. Power companies run simulations they rarely talk about publicly, because they know something most people don't. A Carrington-level event would not be a temporary inconvenience. It would be a test of whether modern society can function without the systems it assumes will always be there. And the uncomfortable truth is this: we don't actually know, because we've never faced it. Not with this much at stake. The first systems to fail would not be the ones people expect. It wouldn't start with explosions or dramatic shutdowns. It would begin deep inside infrastructure no one ever sees, inside transformers, satellites, and control rooms designed for a world that assumed the sun was mostly harmless. High-voltage transformers are the backbone of modern electricity. They are massive, custom-built machines, each one weighing hundreds of tons. They regulate the flow of power across entire regions. They were never designed to handle geomagnetically induced currents. When a powerful solar storm hits Earth, it distorts the planet's magnetic field. That distortion creates electrical currents in long conductors, power lines, pipelines, undersea cables. These currents enter transformers silently and relentlessly. The transformers heat up, insulation breaks down, some catch fire, others are damaged in ways that are not immediately visible, damage that reveals itself days or weeks later, when the system is already unstable. In 1989, a much smaller solar storm knocked out power to 6 million people in Quebec for 9 hours. Transformers were damaged. The grid collapsed faster than operators could react. That storm was mild compared to Carrington. A Carrington-level event could disable hundreds of transformers across North America alone. And here's the part most people don't know: there are no spares. Transformers of this size are not mass-produced. They take months, sometimes years, to build. They are often manufactured overseas. Transportation requires specialized rail cars and routes. If many fail at once, replacement becomes a logistical nightmare. Some areas could be without power for weeks, others for months. And electricity is not just light. It is water pumps, gas stations, hospitals, food distribution, heating, cooling. As power grids destabilize, communication networks follow. Cell towers rely on electricity. Backup generators exist, but fuel deliveries require functioning logistics. Data centers need constant power and cooling. Once backup systems run out, servers go dark. The internet doesn't disappear in one moment. It fractures. Local networks fail. International connections drop. Undersea cables survive physically, but the systems that manage them do not. What remains is silence, broken only by radio, if the atmosphere allows it. Satellites face a different threat. Orbiting Earth, they are directly exposed to the charged particles of a solar storm. Radiation can damage onboard electronics, corrupt data, and permanently disable critical components. GPS satellites are especially vulnerable. Without GPS, navigation systems degrade. Aircraft lose precision guidance. Shipping routes become less efficient. Emergency services struggle to coordinate. Time itself becomes unreliable. Financial systems depend on atomic clocks synchronized through satellite signals. When timing drifts, transactions fail. Markets halt, not because of panic, but because the systems cannot agree on when anything happens. In the early stages, people assume it's temporary, a glitch, a regional outage. They wait. But as hours stretch into days, a deeper realization sets in. This is not localized. This is not human. This is not negotiable. Governments activate emergency protocols. Military assets are protected first. Hardened systems, backup communications, prioritized power. Civilian infrastructure waits its turn. Hospitals switch to generators. Some can last days, others only hours. Fuel becomes precious. Without electricity, refineries slow or shut down. Pipelines rely on powered pumps. Gas stations cannot dispense fuel without electricity. Even if fuel is present, food supply chains fracture quickly. Modern cities carry only a few days' worth of food at any given time. Refrigeration fails. Transportation slows. Payment systems go offline. Cash becomes valuable again. Those who have it eat. Those who don't wait. The psychological impact spreads faster than the physical damage. People are used to disasters with visible causes: storms, earthquakes, attacks. This one has no enemy, no sound, no smoke, just absence. Phones that don't work, lights that don't turn on, news that doesn't arrive. Rumors replace information. Fear fills the gaps. And then there is the question no one can answer. How long will this last? Because, unlike a hurricane or blackout, the damage is not repaired by clearing debris. It requires rebuilding systems from the inside out. Some transformers may never be replaced. Some regions may be deprioritized. Rural areas could wait far longer than cities. In poorer countries, recovery could take years. In the meantime, life reshapes itself around scarcity. People walk instead of drive. Communities form local networks. Technology becomes something remembered rather than assumed. And all of this begins with something no one can see: a storm traveling through space, indifferent to borders, politics, or preparedness. We have already been warned, not once, not twice, but repeatedly. The most unsettling part of the Carrington event is not that it happened in 1859. It is how many times something similar has almost happened since. In July 2012, a massive coronal mass ejection tore away from the sun's surface. It was fast, exceptionally fast, one of the most powerful ever recorded by modern instruments. It missed Earth by 9 days. 9 days earlier, and our planet would have been directly in its path. Scientists later confirmed what many already feared. This storm was comparable in strength to the Carrington event. If Earth had been there, the damage could have rivaled or exceeded anything humanity has experienced. But most people never heard about it. No alerts, no headlines, no emergency briefings, because nothing happened. We were lucky, and luck has a way of running out. There have been other moments too. In 2003, a series of intense solar storms, known as the Halloween storms, disrupted satellites, damaged transformers in South Africa, and forced airlines to reroute flights away from polar regions. In 1972, a powerful solar storm occurred between Apollo missions. Had astronauts been en route to the moon at that time, they would have been exposed to potentially lethal radiation levels. History records these moments quietly. No monuments, no memorials, just data points, reminders that the sun does not care about timing. Modern space agencies watch the sun constantly now. Solar observatories monitor sunspots, magnetic field twists, and eruptions that could become dangerous. But even with today's technology, warning time is limited. Radiation arrives in minutes. Charged plasma follows in hours. At best, we might get a day's notice, a single day to protect a planet-sized machine. Power companies could shut down parts of the grid. Satellites could be placed into safe mode. Airlines could reroute flights. Governments could issue emergency alerts. But not everything can be turned off, and not everything can be saved. Some damage would be unavoidable. And then there is the problem no one likes to talk about: coordination. A global response requires trust, communication, and cooperation, the very things that fail fastest when systems go dark. What happens if one country shuts down its grid to protect itself, while another keeps running and absorbs the damage? What happens when supply chains cross borders that no longer have synchronized systems? What happens when satellites owned by one nation affect services relied on by another? A solar storm is not an attack, but it would test the world like one. And unlike human threats, there is no deterrence. You cannot negotiate with the sun. Scientists have tried to model recovery scenarios. Some are optimistic, assuming rapid repairs, international cooperation, and partial system survival. Others are not. Some models suggest that a truly extreme solar storm could cause economic damage, measured not in billions, but in trillions of dollars. Recovery could take years, not everywhere, but in enough places to permanently change how the world works. Technology would not disappear, but trust in it would. People would remember the moment everything they relied on failed without warning. Governments know this, which is why many preparations happen quietly. Backup transformers are stored in undisclosed locations. Military satellites are hardened more than civilian ones. Emergency protocols are classified, not because the threat is imaginary, but because public panic would be harder to manage than the storm itself. There is an unspoken assumption that modern society is resilient, that we will adapt, that we always do. But history suggests otherwise. Complex systems fail in unexpected ways. Cascading failures multiply damage. Small delays become massive disruptions. And once systems collapse, restarting them is not like flipping a switch. It is more like rebuilding memory. The Carrington event reminds us of something deeply uncomfortable. The most dangerous disasters are not the ones we see coming, but the ones we assume won't happen again. If a Carrington-level solar storm struck tomorrow, the world would not end, but the world you recognize would pause, fracture, and return changed. The first hours would feel confusing, not catastrophic. Phones would lose signal. GPS would glitch. Satellites would drop offline, one by one, not with explosions, but with silence. Screens would freeze mid-refresh. Maps would stop updating. Time itself would feel uncertain as systems drifted out of synchronization. Power grids would begin to fail unevenly. Some cities would go dark instantly. Others would flicker, hold, then collapse hours later as transformers overheated beyond recovery. Rural areas might last longer than megacities, not because they're stronger, but because they're simpler. Hospitals would switch to generators. Some would work, some wouldn't. Airports would ground flights. Elevators would stop between floors. Traffic lights would die, turning intersections into instinct-driven negotiations. The internet wouldn't vanish everywhere at once. It would fragment. Local networks might survive. International connections would fail. Data centers with backup power would become digital islands, isolated from the rest of the world. People would refresh screens, not understanding yet that there is nothing left to load. Within a day, the question would stop being what happened. It would become, when will this end? And for the first time in modern history, no one would have a clear answer. Governments would speak, but not everywhere, and not immediately. Emergency broadcasts would rely on radio, a technology many forgot still mattered. Some countries would stabilize quickly, others would struggle, not because of intelligence or strength. Places with hardened infrastructure, decentralized grids, and spare equipment would recover faster. Others would discover that their most critical components were built overseas, dependent on factories that no longer had power. Global supply chains would snap. Fuel deliveries would stall. Refrigeration would fail. Supermarkets would empty not from panic, but from absence of restocking. Cities would feel the pressure first. Dense populations depend on constant movement. Food in, waste out, power flowing every second. Without that rhythm, urban life becomes fragile. Rural areas might adapt more easily, at least at first. Then comes the psychological shift. People would realize that this was not a cyber-attack, not war, not sabotage. This was nature. And it did not target anyone. That realization would be unsettling in a way modern humanity has not felt in generations. We are used to threats with faces. This one has none. As days turn into weeks, repairs would begin slowly. Transformers take months to build. Satellites take years to replace. Skilled labor cannot be rushed. Some services would return quickly, others wouldn't. Financial systems would reopen cautiously. Markets would stagger, not crash, because crashing requires connectivity. Trust would take longer to restore than electricity. People would remember how suddenly everything stopped, how fragile always on truly was. And this is where the real legacy of such a storm would be written. Not in damage reports, but in behavior. Governments would redesign infrastructure with space weather in mind. Power grids would be hardened. Early warning systems expanded. Emergency planning would shift from theoretical to practical. The sun would no longer be treated as background scenery. Individuals would change to offline skills would matter again. Physical maps, local knowledge, redundancy, not out of fear, but out of respect. Because the Carrington event teaches a final lesson that no technology can erase. Civilization does not end when systems fail. It adapts, but it adapts after humility. In 1859, humanity watched the sky burn green and red, unaware that it was witnessing a warning from the future. Today, we understand that warning. We track it, measure it, model it, but understanding does not grant immunity. Only preparation does. Somewhere on the sun's surface right now, magnetic fields are twisting, tightening, storing energy. They will release it someday tomorrow, or decades from now. There will be another storm, not because history repeats itself, but because physics does. And when it comes, the question won't be whether modern life can survive. It will be whether we remembered the lesson written in fire across the sky in 1859, because the Carrington event was not the end of the world. It was the rehearsal.